we're going to finish 4.3 today. So this is from 4.3. We're going to talk about domain in just a little bit, but right now we're just going to state the transformations. So not graphing, just stating the transformations. All right, what we want to do is identify the parent function. So parent function for logs or exponents is just the base with x. So this is log base 2, so log base 2 of x. And actually I need to have y equals. So I'm going to state the transformations from that parent function. So the -3 on the inside means I'm going to go right 3, good. And then the +1 at the end, good, shifts up 1. Okay, so if you're moving left or right, it will be inside parentheses. And if it's not, like on the warm-up, it's going to be moving up and down. Okay, the next one, the parent function is still log base 2 of x. So that -2 out front is not part of the parent function. Okay, you have to use order of operations, so parentheses first. So you see this +4 on the inside, that means you're going to shift left 4. Okay, so I did that part. I know you see the -2 first, but order of operations, you know parentheses. So you got to do the inside first, and then it's multiplied by that -2. Okay, when you do transformations, the negative is separate from the 2. So the negative out at the very front means you're going to reflect, and you're going to reflect over what? X. The negative out front reflects over x. So now you're just looking at 2. So the 2, the a value out front gives you a stretch or a shrink. And it's 2 bigger or smaller than 1? Bigger, so is it a stretch or a shrink? Stretch. You're not looking at the negative, just the 2. So it's a stretch. Those are the order of operations. Okay, let's look at the domain for this one. So let me just do a quick sketch so we can kind of understand the domain here. So the parent function, you have this vertical asymptote here, okay, and then it's 2 my asymptote here. I reflect over x, and I have a stretch, so something like that. Yeah? Are you okay?
Yeah.
Okay, so if I look at the domain for this problem, then that's my x values. I have a minimum at -4, and then I go to positive infinity. So -4 to positive infinity is my domain. So when I move my asymptote, that's going to affect the domain. The reflection over x, that did not change my domain. Okay, reflecting over x didn't make a difference there. So if I just want to look at the equation to find the domain without sketching the graph, we look at what's just on the inside. So remember, a log function, you cannot take the log of a negative or 0. And that's because no matter what you plug in for y, you're not going to get a negative or 0 for x. And x is the domain. So you just have to solve that inequality, and that will give you your domain. So my original was x plus 4 is greater than 0. Okay? That's all I have to do to find domain of blocks. It's just what's on the inside has to be greater than 0. So I can set that inequality up. Okay? X is greater than -4, which gives me that interval. All right, describing the transformations for this one here. So again, my parent function is log base 2 of x. I have to do a little bit of manipulation here though. I want to rewrite it first with the x first. Okay. So you see the negative in front of x, which you know is going to be a reflection, and then you see the plus 3. Okay, we can't tell our horizontal shift unless it's just x. So I have to do another little trick here and pull out that negative like this. Then I can see my horizontal shift. You see that plus 3 and you're going to want to say you go left 3, but technically because there's a negative, you're actually going right. So you have to do the reflection over y first. That always comes first. If there's a negative in front of x, you have to do the reflection over y first. Everything okay? Yeah. And then you shift right 3. Okay, so that one, that's a little bit tricky. what? Sorry, yes, yes. Yes.
Why do you have to change like what the type of just to figure out that it
Because, so, the formula or the form of a log function is this. Okay? So HK is your horizontal vertical shift, but that's when it's X. Not when it's opposite of X, then it's opposite here of H2. So this is the form, and that negative X throws it off. So you have to take out that negative, so you have your X minus H here. Okay, so reflecting over Y, that is going to affect our domain. But that was again on the inside. So, all right, I'm shifting right 3, but I reflect first. My parent function, my asymptote started here. Reflect over Y first, it doesn't change. Then you shift it right 3. Sorry. Shift it right 3. And your parent function was like this. So you shift that right 3 and then reflect over Y, so it looks like this. Okay, that is going to affect my domain. So now my domain is from negative infinity to positive 3. And if I solve that inequality, I will get that because I have to divide by a negative. So if I solve that inequality, 3 minus x has to be greater than 0. Divide by negative 1. Okay. X is less than 3. So that's the interval, negative infinity to positive 3. So you can still find domain just by taking what's inside the log function, setting it greater than 0. Okay? But that's why that's what it would look like on a graph. That's why it's negative infinity, because you have to switch your inequality sign. Okay, so we're going to do some problems now, just finding domain. Okay, I'm not solving this log, I'm not graphing it, I'm finding domain. So I take what's inside and I write this inequality. And this section is not solving inequalities either. This is finding domain of logs. So to find the domain, you have to create this inequality. Greater than 0, not greater than or equal to. And then solve for x. Okay? And write that as an interval. So greater than negative 3 halves will be negative 3 halves to positive infinity. That is the domain. Okay, let's look at the next one. So you're not going to be asked to graph logs that are this complicated, like when you're taking the log of this function. It won't be that complicated. Just finding domain is all we're doing, finding the domain. So start off by your inequality. Okay. So you were doing the log of a quadratic. to find the zeros of this quadratic, all right, because that's what's going to help me tell what's greater than 0 is if I know what the zeros are. Okay, so you can also call those critical numbers. So I'm going to take out an x and get x minus 2. And right now I'm just finding the zeros. I'm not worrying about the inequality. So I'm just putting equals 0. So that's x equals 0 and 2. Okay. So graph those on a number line, 0 and 2. My inequality is greater, so I'm thinking positive, more than 0, and it's not equal to, so open. So I know I'm going to have open circles here. Okay, when we did this in chapter 3, you sketched the graph of your parabola through those zeros. This inequality is quadratic. The actual function is a log function. It is not a quadratic, but the inequality that I had to use to find the domain is quadratic. And it's positive, so it opens up. So you can do it that way. I'm going to show you another way too, because we'll use this with the rational that we're going to do. So it's just a test. It's a true-false test. You're just going to pick numbers in each of these intervals and see if it satisfies the inequality, if it's true or false. Okay, so find numbers to plug in your inequality. So I need something less than 0, so -1. Something between 0 and 2, +1. And then something greater than 2, which is 3. So plug all 3 of those into this inequality and see if it's true or false. So if I do -1, I want to know, is that greater than 0? That's 3. So is that true or false? True. Okay. So I know that that is part of the solution because it's true. And now do the same thing with 1. So is that true or false? False. Okay. I don't care how much of this work that you show. You can just write these numbers and write true, false, and then this one's also true, true, and have your shading and do your interval. You don't have to show all this work plugging in. Maybe you just do that right in your calculator, or you can tell 1 minus 2, that's going to be a negative. Like, that's all you care. You don't necessarily care that it's -1. You care that it's negative. All right, 3 squared minus 2 times 3 greater than 0. Again, I get 3. I think, yeah, 9. That's true. So, and I have parentheses there. And I can write my domain, which was my goal. And that's -infinity to 0. union 2 to positive infinity. So in order to find the domain of that log function, I had to solve that quadratic inequality. Okay? All right, we're going to look at another one. So this is still find the domain. So to start finding the domain of a log function, so it's natural log, but that's still a log function, okay? So it's still, same properties apply. What you're taking the log of has to be greater than 0. Okay, this isn't a normal function. This is a rational function, just like we had a quadratic function. So, just like with the quadratic, we're going to take out the critical numbers, which would be the zeros of top and bottom. So the zeros of the top would be 2. The zeros of the bottom would be negative 3. Okay? Open circles again. Okay, what's the number I can plug in left of negative 3? Negative 4. What about between negative 3 and 2? 0. Okay, what about right of 2? Okay, plug those in to your inequality. So to this. Negative 4 minus 2, that's a negative. Negative 4 plus 3, that's a negative. Negative divided by negative is positive, so that's true. Okay. 0 minus 2, that's a negative. 0 plus 3, that's a positive. Negative divided by positive, negative. Okay. You can take the time and plug them each in, just like we did here. I'm just showing you a faster way you can think through it, but you can do this, where you plug them in. This is fine. Yeah.
How is the first one true?
So that's negative.
What about negative?
Well, you shouldn't get negative.
Negative 4.
Right, so if you plug in negative 4, that's negative 6 on top and negative 1 on bottom. And a negative over negative is positive, which is greater than 0. So really, since it's greater than 0, you're just looking for positive or negative. That's what you're trying to figure out. Okay, 3 minus 2 is positive. 3 plus 3 is positive. A positive over positive is positive. Okay. So there's my intervals. If you sketched the graph of the parabola on the last one and did the part that was above, You can still do that same thing with this one. It's just harder to sketch a graph of a rational function than it is to sketch the graph of a quadratic. So that's why I like to just do the number line test the numbers. Okay? You good right now? Okay, let's look at one more domain. Okay, start off by the inequality. Write your inequality. So you are taking the log of this radical function. Okay. Radicals, you can still think about critical numbers, but you're only going to have one. All right, let's just solve this. Try to get x by itself. So I can square both sides. Okay. And that's because with radical functions, you're going to have a positive. So the radical doesn't actually matter here, and squaring both sides shows you it doesn't really do anything for your domain. Okay, so solve this inequality, write your interval then, write the domain. So I subtract 5 and divide by -3, which switches the inequality, and I get positive 5/3. So then if I write that as an interval, that's -infinity to positive 5/3. Questions about that? So when you need to find domain of a log, the first thing is to set up the inequality. The inequality will not be given to you. You use this inequality because for log functions, you can only take logs of positive numbers. If you try doing log of -2, like log base 2 of -2, or log base 10 of -2 in your calculator, it's going to give you an error. Okay? Just like if you try to divide by 0, you get an error. If you try to do the square root of a negative number, you get an error. Okay? Okay. So we're going to look at this word problem. This is the formula of the Richter scale, which measures earthquakes. So this is where you see logs. Okay. This is the formula I need for this problem. You do not have to memorize this formula. So after you write that down, take a look at this problem. Okay. So the question asks me, how many times more intense was this earthquake in Chile than the earthquake in Indonesia? So when you want to know how many times more than something, how would you figure that out? What operation would you use? Yeah, division. So I want to divide the two intensities to figure this out. 9.5 and 8.7 are their magnitude, though, not the intensities. So I want to set up this equation for both the Chile one and the Indonesia one. Okay. Also, I see log without a base. So what's the assumed base there? 10. So I need to know that. I need to know that that's base 10. Okay. All right, so the magnitude for this earthquake in Chile was 9.5. I don't know its intensity, so I'm just going to put I as a little c, because that intensity is different than the one in Indonesia. Okay, and then I also don't know the reference intensity, but that's going to be the same, because they reference intensity. It'll be the same for both earthquakes. Okay, so again, what I'm trying to do is how many times more intense. So I want to divide the intensity of Chile by the intensity of the Indonesia. Okay, so that's what my goal is to do that. So I need to find their intensities first. That's what I want to work towards, so I can then divide them. And I'm sorry, I forgot the log down here. So this is log base 10. Okay. Now let's do the same thing for the Indonesia. But this time the magnitude was 8.7. Okay. So to get rid of the log function, what we'll learn in 4.4 is I can exponentiate both sides. But we haven't got there yet. So to get rid of the log function, rewrite it in exponential form. So that's key to this problem. There is a word problem on your quiz where you'll need to rewrite it in exponential form. Okay, so it's log base 10, so 10 is the base. The answer to a log problem is the exponent. Okay, so 10 to the 9.5 equals this fraction. Okay, do the same thing for Indonesia. Remember, I want this and this. So I'm going to just multiply by I sub 0, by the reference intensity. Okay? So thing over here. So I'm going to get I sub 0 times 10 to the 8.7. Okay? Set up. So that gives me their intensities. Okay? Now, set this up so you can figure out how many times more intense. This is why the reference intensity does not matter for this problem. I don't know exactly how intense each one was. So what I'm looking for is their comparison. Those cancel, meaning all I need to do is 10 to the 9.5 over 10 to the 8.7. To make it easier, you can subtract your exponents, so that's 10 to the 0.8. And then just round to the nearest tenth. Okay, you should get 6.3. So it was 6.3 times more intense. Okay, before packing up, I have a little bit, one more thing to show you really quick. So on the calculator part of your quiz, you are going to be asked to evaluate some common logs and natural logs, so the buttons that are on your calculator. So I want you to find the buttons so you know where they are. Okay. These are really easy because you're just typing it in your calculator. Okay, so that's log base 10. That's on the left side of the graphic calculator. These are unscientific calculators too. You don't need a graphic one. These are only going to be 1 point because it's just you typing that in. If you round incorrectly, you will not get it right. You will miss a point. So 5 decimal places is after the decimal point. Okay, so that's what you should get there. Okay, now do natural log. Okay. All right. So everybody able to find those buttons on your calculator?